Let's solve LeetCode 49 group anagrams. So given an array of strings, group the anagrams together. You can return the answer in any order. What does anagram mean? We have seen that in a previous LeetCode problem, which is valid anagram. So this LeetCode 242 problem tells us that given two strings s and t, we want to return true if t is an anagram of s and false otherwise. And what we did here is essentially check that each character of the string s is equal to each character of t. Essentially the counts of the characters in s should match the counts of characters in t. That is what anagram means. And now in this problem, what we need to do is, given an array of strings, we want to group all of the anagrams together in one list. For example, if you have a list like this, we'll have an output of bat, nat and tan in one list, ate, eat and tea in another list. Why? That's because there is no string in strings that can be rearranged to form bat. In this, you won't find any other string other than bat that would give an anagram of bat. The strings nat and tan are anagrams as they can be rearranged to form each other. If I take t from the last position, put it in the front, n from the first to the last, we have tan. The same goes for these three strings. They're anagrams of each other. So that's what we want to do. Iterate over this list. Then we want to compare that the counts of the characters in each word is equal to the counts of other words. Essentially, like, the counts should be grouped together. That's what we are trying to do. So let's take an example. Let's say we have the same example of eat, tea, tan, bat, and let's say 8. How will we do this? Well, first of all, we know that we need to compare the count of every word, right? So that would mean I have to iterate through this entire list. So I'll go over every element in this list, and then I have to go over every character of every word. That's how I'm going to get it. So I know that the time complexity should be O of n into m, where n stands for the number of words in the list and m stands for the number of characters, the average number of characters in each word. And in our case, as you can see, like, all of these are 3-letter words. So in our case, m is just 3. But yeah, we're going over every single one of them, right? So yeah. So this is the time complexity we are targeting because we don't need to have anything else that we need to optimize for. Like, it shouldn't exceed this because we know we just have to go over every character in the word. And for every word, we need to do this. So let's see how we can do it. First of all, we're just going to start a for loop, correct? So what we do is for every word in this strings list, we'll get the word. And for every word, we are going to go through every character in the word. And after that, we essentially need to create an anagram map, right? Because in the valid anagram problem, if you remember, we had t and s strings. So let's say we had 8 as t and s is eat. What we did here is created a t dictionary and we created an s dictionary. And what we had is a count 1, t count 1, and e count 1. The same goes over here. E count is 1, a count is 1, and t count is 1. So as you can see, they are both equal to each other. That's how we compared. The same thing can be done over here, right? So what we can do is for every word, we are going to create a new dictionary. So we have a mapping that's created here. And then we can just assign the mapping here. Let's say new at character plus equals 1. Okay. And we'll just say that this default dictionary has a count of 0. Okay. So if any character is not present and we're doing new at character, it won't throw an error. Instead, it will initialize it to 0 and add 1 to it. Cool. So yeah, that's the mapping that's created, but we're not storing this mapping anywhere, correct? Because for every word, we are creating a new map. So as soon as we complete eat, we go to t, the mapping we create here is lost. We start with a brand new variable that keeps track of t. Well, we want to store it somewhere, right? And what we can do here is store it in another map, right? Because then we can have that mapping here. So mapping would be something like this. This is the bigger mapping. This mapping would be like a bigger map which has key as the map, which is the smaller map that we have, the word mapping. So let's say A as 1, T as 1, and E as 1. This would be the mapping. And then there would be a list of elements that have the same key. So eat has this mapping, ate has this mapping, and T has this mapping. So all of them will go into a list. And then to return the answer, what we can do is this mapping dot values. So we'll get all of the values that are stored here in a list format, and that would give us the output like this. So that's what we are trying to do, but there are some problems. The problem with this situation is that you can't have a map as the key in Python. That's because keys or maps are supposed to be hashable. The keys of the maps are supposed to be hashable. And in our case, we're using map as the key. And map or dictionary by itself is not hashable. That's because maps are mutables. If you want something to be a key of a map, you need it to be immutable. For example, a tuple. A list is also mutable, so you can't use a list as a key, for example, but you can use a tuple. That's because tuples are immutable. So that means you can't modify the values within the tuple. And that's what we want as the key. Now, if you want to know why that is the case, we'll probably understand that in a future LeetCode problem where we try to build our own hash map. And that would be a simple hash map, but it would give you an understanding of why that's the case. I don't know if it's going to come or not, but yeah. Anyways, so we can't use a mapping here. What can we use instead? As I said, we can use a tuple or a tuple, however you want to call it. How can we use a tuple? Well, if you think about maps, what are they doing? They're keeping track of alphabet to some count. So how exactly is a hash map implemented? They're essentially implemented using lists. At index 0, what value do you have? At index 1, what value do you have? At index 2, what value do you have? That's essentially what a map does. So when you call a function like, let's say, enumerate in Python, and you enumerate over a list, for example, you get I, and then you also get access to a number, correct? So I is the index and num is the actual value that's present. If you do this over a map, what is it going to be? Well, I'm not sure if you can do enumerate over a map, but if we could, then we would do map.items or something. But yeah, what we're doing is getting the key and the value. So that's what we're trying to do. What we can do here is that we can, instead of using this map, create a tuple. And what this tuple is going to do is that, let's say we have A. A is the first alphabet in our English language. That's what we know. So what we can do is at index 0 in the list or the tuple, we can store the number of A's present in the word. Then we can do the same thing for T. So let's say T is some other number. I'm not sure what that is, but we'll dynamically calculate it. And let's say T was 15, for example. So at index 14, because our indexing starts from 0, at index 14, we are going to increment T to be 1. And the same goes for E. E, I think, is 5. So we can put at index 4 a 1. And rest of the values are going to be 0. And then what we can do is store that as the key. And that would essentially have the same effect because 8, eat, and T are going to have the same tuple. But here's the problem. As I said, tuples are immutables. So you cannot add value to them. You cannot modify their value. So what can we do now? Well, what we can do is use a list here. So instead of using a tuple, we are going to create a list. And then after that, we are just going to convert that list into a tuple. Works? And then we can use that tuple to be the key. I know it's tough to understand, but if we code it out, I think you'll understand. What I mean by that is, let's say we have for element in strings. Let me just call this word. And after that, we're just going to create a list. What this list does is it contains the number of counts that are present within this. So the number of the count that is present for each alphabet in the word. So we'll have, let's call this count, which is equal to, and we're going to create a list, as I said. And I told you that all of the other values are going to be 0, right? Because, for example, B is not present in the word eat. It only has E, A, T. B is not present. So B is going to be set to 0. E, A, and T are going to be 1. So what we can do here is 0 multiplied by 26. Why have I done this? What I've done is for each alphabet, I've initialized it to 0, and there are 26 alphabets. How can I be sure that this strings is going to contain only 26 characters? And that's an important assumption. And we are taking that assumption because it's given to us. Strings at I consists of lowercase English letters. If this was not given, this would be a problematic situation. So keep that in mind. If you're coding in another language, this would be kind of like an array list then. But now you can just use an array. After that, we can go through every character in the word. And then what we need to do is update this count list. Now what I want to do is at index 0, I want to create kind of a mapping that A corresponds to 0, E corresponds to 5, and T, I don't know what it corresponds to, but maybe it's like 15, 20 or something. So that corresponds to 15 or 20. How can I create that mapping? So if you want to take a naive approach, you can just create a mapping that, hey, E is, or let's just start with A is 0, then B is 1, C is 2, and so on. But I don't like that approach because we'll have to do it for 26 characters and it's not extensible either. If we have to do it for, let's say, not just lowercase English letters, even for uppercase English letters, we'll have to do this as 52, and then I'll have to include A as some other character as well. I'm not ready for that. So what I can do instead is make use of something known as ASCII. ASCII stands for American Standard Code for Information Interchange. It's a character encoding standard that uses binary numbers to represent English letters, numbers, and other symbols. Let's skip that. I'll just show you the ASCII table and you'll understand what I'm talking about. So if you look at this list, 65 stands for capital A. That means if we use ASCII, capital A will have the value of 65. B will have the value of 66. And C will have a value of 67 and so on. But we're not interested in capital values. We're instead interested in lowercase values. And for lowercase, A is 97. So what I can do is find out the ASCII of A, which is 97, and subtract it for every element. So let's say I have E. I can find out the ASCII of E, which is over here 101, and I subtract it from the ASCII of A, which is 97, and I get the index of 4. Then in this count variable, I can update the index at 4 to increase its count by 1 because we found a character at that position. Cool? If we do the same for A, for example, A minus A will give us 97 minus 97, which is equal to 0. So that's the approach we're using. So to count out the ASCII value, what I can do is ASCII value, or if you want to call this index, you can call it index, which is equal to the odd of char. This is how you find out the ASCII value, and you minus it with the ASCII value of A. Now, if you want, you can put over here 97, but I'd like to be more dynamic. After that, we can just update the count. So count at index plus equals 1. Why am I doing plus equals 1? That's because let's say initially the value is 0, it will increment to 1. But let's say we have a word that is having multiple characters. For example, Rivan. Here we have 2 A's. So what we need to do is in the index 0, A will be 2, right? I mean, at index 0, it will be 2 because there are 2 A's. And rest of them are going to be 1. For example, N is 1, V is 1, I is 1, R is 1, etc. So that's, and obviously the rest of them are going to be zeros. But yeah, that's what we are trying to achieve. So that's what I've done with this. And now what I can do is, well, put all of this count into a bigger mapping, because we know we want to store this bigger mapping and then essentially return the value. And we created that logic over here. So we are going to have a mapping where the key is a tuple and the value is a list. The list will contain the values. For example, ATE will contain EAT, then it will also contain 8, and then it will also contain, let's say, T. So this is the values that we are going to store. And for that, we need a dictionary whose default value is a list, because we are going to directly append to that list. So what I can do is create, let's say, result, which is equal to a default dict. Default dict comes from a Python library, standard library called collections. We don't need to import that in LeetCode, but that's a good thing to keep in mind. After that, what we can do is for result, add this tuple of count. Remember, I'm converting this list into a tuple because if I use just a list, it will give me an error. So I'm converting it into a tuple, then I'm appending to it because with this, I get the value, right? So I'm going over this dictionary, I get its value, and I'm appending to this list some value, and the value I want to append is the word itself. So if let's say we have eat will be a tuple where it would be something like this, a dictionary where the tuple is, let's say, 0, 0, 0, 0, let's say 1, comma, and then we have some zeros and ones again. Cool. And then there would be a list here which would contain, let's say, eat, because EAT, like they form a tuple. The same goes for T, and it will form the same tuple because the same ones will be present, the same zeros will be present, so they'll go into the same place. And the same goes for 8. Now that we have this, what we can do is get all of the values of this dictionary and then return it. For example, bat. So A will be 1 for bat, A will be 1, B will be 1, and then you have a bunch of zeros. And then for 1, you have T. So you have 1 here and then something like this. And then you return, you have a list here, you just have a bat within it. So what we are trying to do is get all of the values. So it will pack up in one list, which contains sublists. And that is our output over here. So what I can do is just return response.values or result.values. Now, if I just run this, it's most likely going to give an error because this is Python 3. The types are different here. As you can see, dict values is not a valid value for the expected return type. So what I want to do instead is just convert it into a list before returning it. This returns a dict values. It doesn't really return a list. So yeah. And now I think it should work out. So yeah, it does. I'll submit it. And there we have it. The time complexity over here is O of n, where n is going over every word, multiplied by m, where m is going over every character, or like the average number of characters in the list. So average number of characters of a word in the list. And then you can also multiply it with 26, by the way, not 52. 52 worked out because, well, you know, after 26, everything is 0, because odd character minus odd of a, where everything is a lowercase English character, is always going to be within 26 characters. But yeah, uh, everything after 26 was 0 anyways, so it didn't matter. But just make sure this is 26, better efficiency, better memory efficiency. And now what we've done is we'll also have to multiply it with 26, right? So of O of n into m into 26, because for every count, we are also creating a tuple here. And when we convert a list into a tuple, it takes O of n time, where n is the number of elements in the list. And for us, every time it's 26, so O of 26. So it would be O of 26 n into m, but since we remove constants, it's just O of n into m. Now the reason we are saying that this is O of 26 into n into m and not O of n into m into, let's say, n, is because this is a constant. It's 26 fixed. We use n and m where, the input size is with respect to the input parameters. So n is the number of words in a string, or number of words in the list. So that is why it is called n, because it is dependent on the input. The same goes for m, the average number of characters in the list. So that is also dependent on the input. But this one is not really dependent on the input. This is a constant every single time. If the input changes, this won't change. Cool. So that is our solution. I'll just run it once again because I changed it to 26. And yeah, we have it.